Morning students. Yesterday or in the previous class we all had studied about the proposition and the connectors and some basic terms depending on the Boolean algebra. Right? So you all had copied the question answer and learned the topics. Okay? So the topics were which has been explained, that is proposition, the types of proposition, the terms related to the propositions. It is being explained to you in the previous topic. So now the new topic we are going to study, that is basic logic gates. Now basic logic gates, if we see students, that logic gates generally it is being used for switching circuits in algebra. Clear? Because Boolean algebra has been applied to computer electronics, so this logic gates, with the help of logic gates, the circuit diagram is being created. Now, what is a logic gate? So logic gate, you can see that definition is being given over here, that logic gate is simply an electronic circuit which operates on one or more signal to produce an output signal. Clear? Now, let me explain you. Here this is. Right? So, gates are the digital two-state circuit. If we see, the two-state circuits. Two-state circuits. Here two-state circuits. That is, you can say that input and output signals. So here low voltage you denotes to 0 and high voltage denotes 1. Clear? That means 0 denotes false and 1 denotes true. So there are three types of basic fundamental gates: inverter gate, that is NOT gate, OR gate, and AND gate. These are the three types of gate. First gate we are going to study about the inverter gate, that is also known as NOT gate. Clear? NOT gate, generally it is being termed that it is only one input signal and one output signal, such as the diagram for this gate will be one input signal and gate will be drawn like this, and one small circle will be placed at the last, and such as the input is A, so the output will be A bar. So this will be your NOT gate. Clear, students? So NOT gate is being explained. The NOT gate truth table, you can see students, here this is the NOT gate truth table is being defined. When the input is 0, the output is 1, and the input is 1, the output is 0. So this is the circuit diagram for a NOT gate or the inverter gate. Clear? Now next come to the next topic, that is OR gate. Now OR gate means which has two or more input. That means OR gate is a kind of a gate which is having two or more than two inputs, and it gives one output. Clear? In the OR gate, you can see that OR gate, this is the symbol of OR gate. This is the 2 input, this is 3 input, this is 4 input. So as many as number of inputs are there, more than 2 inputs are there, but the output will be 1. So how it is produced output? You can see the 2 input truth table is being drawn over here. This is the 2 input. When 2 inputs are there, X and Y, and we will give the binary combination 0 0 0 1 1 0 1 1, the output will be 0 1 1 and 1. Why? Because any of the input is 1, it will gives you output 1, right? So this is your OR gate. If we see the 3 input OR gate, the truth table is being defined over here. 3 input means 2 to the power n. So the number of total input combination, that is, if you see 2 to the power 3 inputs, so 2 to the power 3 equals to 8. The total number of input combination, you can see over here 8 combinations are there. So starting from Z, 0 1 0 1 combination, Y 0 0 1 1 0 0 1 1, X 4 times 0 and 4 times 1. These are the binary combination of the decimal numbers such as 0, 1, 2, 3, 4, 5, 6 and 7. Clear? Now let's move to the AND gate. If we see the AND gate is the also having two or more inputs and produce only single output. So you can see over here, if any input or the continuously two inputs having one or input is true, then only it will gives you output 1. Otherwise it will gives you 0. So just see the definition and learn the definition. The AND gate can have two or more than two input signals and produce an output signal. When all the inputs are 1, that is high means 1, then the output is 1. Otherwise it will output 0. Clear? Next, let's see the truth table for the AND gate. If you see, students, let me explain you first about the AND gate, how it is being created. Two input are there. In the form of D it is being created, and if we see the truth table of this two input, that again when the input combination all are ones, then only it will go ones, otherwise the answer will be 0. Clear? This is the 3 input gate and 3 input truth table. So the symbol which is being used, such as the F is being given, so F equal to X dot Y. For the 3 input, the F will be equal to X dot Y dot Z. Okay, students, so in the previous videos you all had seen that I had explained you about the basic fundamental gates, that is NOT gate, AND gate and OR gate, with the help of truth table and its diagram. Now let's see the next topic, that is principle of duality. Now here the principle of duality states that plus operator changes. Just read the first point. Here OR sign, that means plus changes to dot, and the second point dot changes to plus, third one 0 changes to 1 and 1 changes to 0. Clear? This is the principle of duality. But one more thing important in this, that the complement will remain the same. For example, if we talk such as one expression it is given, if I would say I am giving you an example over here, such as it is written a plus 0 equals to b plus or b bar plus 1. If you want to convert this duality, or if you want to write the duality for this, so the answer would be a plus becomes dot and 0 will be 1 equals to b bar remains same and plus becomes dot and 1 becomes 0. So this is the answer of duality. Clear? So this is the basic principle of duality, and it is very important principle in Boolean algebra, which states that the starting with a Boolean relation, another Boolean relation can be derived with these relations. Now, as previously I had in the last video, I asked you that the Boolean laws will be explained in the next video. So here the Boolean laws, now we are going to start. That is because Boolean laws are very important to generate the relations or to calculate the Boolean algebra expressions to create the circuit diagrams. Such as you all studied in mathematics, the algebra formulas are there: a plus b whole square equal to a square plus b square plus 2ab. In the same way, the Boolean algebra having some Boolean laws. On the basis of this, you can calculate or reduce the Boolean expressions. So let's move. The first law is the property of 1 or 0. Both has been explained over here, properties of 0 and 1. If we see the property of 0 and we are adding or 0 plus x. Now let's see, 0 plus x will be equal to x. Why? Because for example, if you see 0 plus x, we are assuming 1. So the answer will coming 1. If we are finding 0 plus 0, the answer is coming 0. So you can see the answer is coming as same as x, such as this is x and this is 0. So here you can see the answer is same. So that's why the relation states that 0 plus x equals to 0. Now come to the next relation, point number B, that is 1 plus x equals to 1. Now let me explain you about this with the help of truth table, such as 1 x, if we see 1 and this is 1 plus x. Now if we are calculating 1 plus 0, it will gives you 1. If I am calculating 1 plus 1, it will giving 1. So you can see that whenever it is being calculating, the answer is coming only 1. That's why it states that 1 plus x equals to 1. Now let's move to the third relation with the help of 0. 0 dot x equals to always 0. Let's see how. Such as I am making a truth table, 0 x, and here we are finding 0 dot x. So this is 0 0. Now I am giving value 1 0 and 1 1. So if we want to find 0 dot x, that means 0 dot 0 will gives you 0, 0 dot 1 will gives you again 0. So you can see the result that it always 0. That's why the third relation, point number C, 0 dot x equal to 0. Now come to the fourth one, the property of 1, that is 1 dot x is always equals to x. Let's see how it is. So 1 and x we are giving. Here you can see I am writing 1 1 x, and the answer will be 1 dot x we have to find. Here I am giving 1 0 and 1 1. So the answer 1 dot 0. What is 1 dot 0? 1 dot 0 will be 0. What is 1 dot 1? 1. So you can see the 0 1 answer is coming as same as the input is x. So these both are same. That's why the relation states that 1 dot x equals to x. Clear? Understood, students? Okay. The second law, that is idempotence law. You can see idempotence law. Idempotence law means, actually idempotence is a word which means same. So there are two laws. First law, x plus x equals to x, and x dot x equals to x. If we see with the help of truth table, such as this is x, and we have to find x plus x, and second one we have to find x dot x. So I already told you the number of input combination will be 2 to the power n. So here how many inputs are there? Only one input is there. So 2 to the power 1 will equals to 2. So only 0 and 1 will be there. So let's see x plus x, that means 0 plus 0, 0, and 1 plus 1, 1. In the same way, x dot x, 0 dot 0, 0, 1 dot 1, 1. So you can see that all the relations are same with the equivalent to input x. That's why these two laws states that x plus x equals to x and x dot x equals to x. Clear, students? Now move to the next law. Excuse me. That is involution law. Now involution law is very simple law. Simply when you find the involution law, such as you can see in the truth table also, which I want to draw, the involution law, if x input 0 1, we will find the x bar, that is the complement. So 0 becomes 1 here and 1 becomes 0. But again when the one more bar is being placed, so 1 again becomes 0 and 0 again becomes 1. So you can see that this output is as same as the first input. That's why x double bar equals to x. This states involution law. Now let's move to the next law, that is complementarity law. Here complementarity law, complement, the complement word states the complement, that is bar. So the first law states over here, you can see, students, here. Now you are able to see properly. First law x plus x bar equal to 1 and second law x dot x bar equal to 0. So here you can see that x I am taking one input and x bar we are finding. So when the 0, 1, x bar will be 1, 0. You have to find x plus x bar first. I am finding x plus x bar. So x plus x bar will be 0 plus 1, 1, 1 plus 0, 1. So you can see the output always relates 1. So this indicates the first law. Now the second law, in the same way, x, such I am writing or finding the x bar. Now I have to find x dot x bar. So here 0, 1, इसका हो जाएगा बेटा 1, 0. Now x dot bar 0 dot 1 will be 0 and 1 dot 0 will be 0. Clear? So you can see the output is 0. So here the output is 0. It states. So this is the proof for this law. Now let's move to the next law, that is commutative law. Commutative law you already studied in mathematics as also. Commutative law states that first one, x plus y equals to y plus x and x dot y equals to y dot x. So it is as same as you all know, when we draw the truth table for such as x, y, two inputs are there and we are finding x plus y or y plus x. Y plus x. So the answer will be same because 0, 1, 0, 1, 0, 0, 1, 1, x plus y, that is 0, 1, 1, 1. In the same way, y plus x, 0, 1, 1, 1. So in both the same way, you can say the output or the result will be same. Now move to the next law, that is associative law. Here associative law means that only the bracket will be changed. See, x plus bracket y plus z, and same it is written on the right hand side, x plus y plus z, only the bracket will be changed. Clear? If we see the truth table, see over here students, here this is the truth table for associative law. So you can see that three inputs are there, three inputs we had given. So as I had explained you before, that how many number of inputs are there, 2 to the power n, that is 2 to the power 3, which gives you 8. That's why total number of combinations are 8. 1, 2, 3, 4, 5, 6, 7, 8. So first of all we are finding x plus y plus z. So here we had find a y plus z, and here we had find x plus y. We are finding here x plus y plus z. That means you will pick up this first column, this first column, and y plus z. So you will add between the operator or operator in these two. So you can see 0 plus 0 will gives you 0. 0 plus 1, 1. 0 plus 1, 1. In the same way, all the result will come. Now, next to the next part, if you see over here, y plus x plus y. So you will see this column and z, that is this column. Clear? So you see that 1, 0 plus 0, 0. 1 plus 0, 1. Clear? 0 plus 1, 1. In the same way, all the result generated. Clear, students? Okay, here the next law is your distributive law. Distributive law, there are three laws. First, the law states that x plus, you can see over here, x dot y plus z equals to xy plus xz when you open in the form of algebraic. So when the if you open in the form of algebraic, that gives you xy plus xz. Clear? So the proving is being done over here with the help of logic gate, and the second law is your x plus yz will gives you xy plus xz. Clear? These are the two basic laws. Now let's see the proving for these laws. So this is a truth table for, you can see over here, students, that x bracket y plus z equals to xy plus xz. Now how? There are three input variables. So first of all, we had find y plus z, then we had find x dot y, then we had find xz, and after that we found the left hand side. This is LHS and this is RHS. So while finding, you can calculate and you can see that these two results are same. So it states that x bracket y plus z equals to xy plus xz. Now let's move below. It is being explained with the help of algebraic form. Now one more third law it is there. Let me explain you over here. I am writing this third law. These are the two laws. One such as I am writing x bar y. So it will gives you x plus y. Now let's see how it will be given to you. I had written, I am writing again, x plus x bar y equals to x plus y. How it will be generated? Let's see. If you see this x plus x bar y, if we apply the distributive first law, so second law, x plus x bar dot x plus y. Clear? Now let's see this x plus x bar. By applying complementarity law, it will gives you x plus x bar is 1. So 1 dot x plus y will always return, this is the property of 1, x plus y. Clear? So this is the final result. Clear, students? This is the distributive third law. Now let's move to the next law, absorption law. If we see the absorption law, it's also very good law. It absorbs a variable and gives you only in the form of one variable. Let's see the first law. It states that x plus xy equals to x. Now let's see how it can be found. If it is given x plus xy, clear? So now I am taking common in this. I am writing again over here x plus xy. Clear? Now I am taking x common into this, so it remains 1 plus y. Now by applying the property of 1 plus y will becomes 1. So x dot 1 equals to x. Clear? This is the proving of the first law. Now let's see the second law, absorption law, x dot x plus y equals to x. Now we are taking left hand side. Let's take left hand side, that is x into x plus y. If we see, we will open the bracket, it will gives you x dot x plus xy. Clear? Now let's see, this is your idempotence law. By applying idempotence law, it will gives you x plus xy. So here you can see, students, again this is the first law. Clear? This is the first law, and first law states x plus xy equals to x. So this way the second law states x into x plus y equals to x. Clear, students? Okay, so these are all the laws which I had explained you, Boolean Algebra laws. Clear? From here you can copy all the laws and understand well. You have to practice these all the laws with the help of truth table. Prove it on your own in your notebook, students. Clear? The PDF of the following or the content which I had explained you, I will provide you. I will give you the PDF for the contents which I had taught you.